future data centers may have built-in nuclear reactors. Now, I don't know why it sounds so
What could go wrong?
Now, the latest development from Google that it describes as a state-of-the-art quantum computer chip.
Right now, as you're watching this video, there are probably 50 billion flash memory chips working silently around you. Your phone, your laptop, your smart TV, even your car, they're all powered by a technology that's hitting a wall so hard, the entire tech industry is scrambling for alternatives. In this video, I'll show you exactly why the storage revolution that changed everything is about to change again, and the 3 breakthrough technologies that could replace flash memory entirely. But first, you need to understand how we got addicted to something that was never meant to last forever. Here's what nobody tells you about flash memory. It was never supposed to take over the world. Back in 1980, Dr. Fujio Masaoka at Toshiba was trying to solve a simple problem. How do you store data without power? But here's where it gets interesting. Masaoka didn't just create one type of flash memory. He created 2 completely different architectures that would accidentally conquer different parts of the tech world. And this dual approach is exactly why flash succeeded where other storage technologies failed spectacularly. Think about this. Every device you've owned in the last 15 years has been shaped by one fundamental shift: the elimination of moving parts in storage. Your smartphone exists because flash memory made it possible to create something thin, durable, and power efficient. Your laptop boots in seconds instead of minutes because of SSDs. Even your car's navigation system works reliably because flash memory can survive the vibrations that would destroy a traditional hard drive. But here's what's fascinating. This wasn't planned. The consumer electronics revolution happened because flash memory accidentally solved problems that device makers didn't even know they had. By 2022, the global NAND flash market hit $60 billion. That's larger than the GDP of most countries, all built on storing electrons in tiny floating gates. But this massive success story has a dark secret that's about to change everything. Here's the problem that keeps flash memory engineers awake at night. Every time you write data to flash memory, you're literally wearing it out. Those floating gates I mentioned, they can only trap and release electrons a finite number of times before they break down completely. And it gets worse. As manufacturers try to cram more data into smaller spaces, they hit what's called the physics wall. When memory cells get too close together, they start interfering with each other. It's like trying to have a conversation in a crowded room. Eventually, the noise becomes overwhelming. If we don't solve this, we're looking at a future where your storage devices fail faster, cost more, and perform worse, just when AI and data processing demand exponentially more storage capacity. But while flash memory is hitting its limits, 3 revolutionary developments have appeared. After analyzing the latest research and industry developments, 3 technologies are positioned to reshape storage forever. First, 3D XPoint technology. Imagine storage that's almost as fast as your computer's RAM, but never loses data when you turn off the power. Intel's Optane technology bridges the gap between memory and storage, offering 1,000 times better endurance than flash memory. Second, MRAM, magnetic memory. This uses magnetism instead of electrical charge to store data. The result? Instant writes, unlimited endurance, and the ability to retain data for decades without power. Third, ReRAM, the AI accelerator. Here's where it gets really interesting. ReRAM doesn't just store data, it can process it. This means your storage device could literally think, making it perfect for AI applications that need to process massive datasets instantly. Major tech companies are already betting billions on these technologies. Samsung, Intel, and IBM have all announced major investments in next-generation memory research. But here's the twist. The future isn't about replacing flash memory entirely. It's about creating intelligent storage hierarchies where each technology does what it does best. Your future computer might use MRAM for instant-on capabilities, 3D XPoint for active data processing, advanced 3D NAND for mass storage, and ReRAM for AI acceleration, all working together seamlessly. So, what does this mean for you right now? 3 things. First, if you're buying storage today, understand that we're in a transition period. Current flash-based SSDs are still the best choice for most people, but expect dramatic changes in the next 3 to 5 years. Second, the data explosion driven by AI, 4K video and IoT devices means storage demand will increase 50-fold by 2030. The companies that solve the post-flash puzzle will dominate the next decade of tech. Third, this isn't just about faster computers, it's about enabling technologies we can barely imagine today, instant-on devices, AI that processes data where it's stored, and storage systems that last decades instead of years. But there's something else we need to talk about: the environmental impact. The current flash memory industry generates massive amounts of e-waste and consumes enormous energy. The next generation of storage technologies could be our chance to build a more sustainable digital future. What storage breakthrough are you most excited about? Drop a comment below, and if this changed how you think about the technology in your devices, hit that subscribe button. I've got 3 more videos coming this month that will blow your mind about the hidden technologies shaping our digital future.